HeatSpring site. So some excellent content for understanding how to navigate different types of topography and vegetation. Today, though, we're going to review the optimal environmental conditions for flying, what hardware and filters to consider, what camera settings are best for various circumstances, and several examples from projects around the world. We also will do a deep dive into what is photogrammetry. I'm going to hide my video here so you can focus on the slides that are going to come up, and I'm going to walk you through a brief introduction. Okay, great. So to start, I want to walk you through a few images to set the scene. And do any of these resonate with you? That's what I'd love for you to think about, right? So first, we have sun glare. This is often found at dawn, dusk, or midday, okay? There's whiteout with direct sunlight mixed in with trees or white roofs or facades. Beware of light reflecting off of a metal roof and affecting the camera's lens. And then significant or intermittent cloud coverage or flying at dusk can lead to some images being dark. And that lighting difference, whether it's darker or lighter, will create color inconsistency and can lead to texture map discoloration and possibly even a modeling error. Okay. And then finally, images taken when the drone is flying too fast or foggy weather or really dark conditions can create blurry images. And this diminished clarity will cause sight features to not map so well, right? So these are the types of images that we're trying to avoid, and this is what we want to help you perfect and clarify, all right? So to start, I want to get a sense from everyone how relevant this issue is for you, right? Do you experience these problems while you fly? Is it something that you see most commonly? Is it something you see never at all? Are you not really sure, and that's why you've joined us? Awesome, thank you, Brian. So we just launched our first poll. We're gonna have a couple of these throughout the webinar, and we're gonna try to learn from everyone as to these problems and also how we can solve them. So when you get a chance, please select how you resonate with these problems, and then we'll continue on from there. Okay, we'll give it a couple more seconds to let people fill out. Again, our goal is here to understand from the larger audience, are these problems things that resonate with you as you're trying to best capture survey data and also analyze the projects that you're creating? Okay, we're wrapping up now. Get your final answers in, and we're about to close the polls. Okay. Let's close them and let's share those results. So it seems like a significant majority, well, not a majority of people say they face these problems sometimes, which I think makes sense depending on where you're located geographically and what time of day you fly. There's a lot of people who say they're not really sure, and I think that's great because you've joined us today to figure that out. So that's fantastic. Great. All right, so we can close the poll now. Okay, and let's do one more poll. Starting to get into the guts of what this presentation entails. So at a high level, do you know what exposure is? If you do, that's awesome. Hopefully you'll still have plenty of things you'll learn from us. If you don't, you've come to the right place. And if you say, I think so, that's probably right down the fairway, because I think most of us have a general sense of what it is, but when we talk specifics, it's still a little bit opaque, to be a bit punny with that. So fill out the poll. Give us a sense for your knowledge of the topic at hand, specific to exposure, and then we'll address some of the other ones as we go forward. Okay. We're just finishing up, get your answers in, and then we're going to release the results. All right, let's close those polls. Okay, great. So the majority of people are aware of what exposure is, which is fantastic. And I think a remainder of the group is not sure or might not know. And so that's okay as well. From a purely definition perspective, right, a photograph's exposure determines how light or dark an image will appear when it's been captured by your camera. And believe it or not, this is determined by just 3 camera settings: aperture, ISO, and shutter speed, what is known as the exposure triangle. This is clearly tied to lighting, glare, and all the elements that were reviewed in the prior images that I showed you at the start. And Keith will walk through a lot of the more specific items when it comes to this in his portion of the presentation. Okay, great. All right, so where are we going to go from here? What are we going to cover in this presentation now that we've set the scene? I'm going to provide a brief overview of Scanifly, so you have a good sense for who we are and what we do. We'll also introduce our other partners throughout the presentation. We will also do a deep dive on what is photogrammetry, right? The underlying foundational technology that drives this process. We'll also talk about different project examples. And both numbers 2 and 3 will be done by my colleague, John Novak. Keith at Hudson Valley Drones will then discuss in great depth strategies for managing exposure in the future. And so he's going to talk about camera settings as well as navigating your hardware in particular. So we're going to cover all of these. We're going to save a bunch of time for Q&A as well. Okay. So just to start out, right, Scanifly's goal is to remove the inefficiency and human dependence in the solar workflow. Our team consists of nearly all solar professionals, so we've experienced a lot of the workflow firsthand. Problems like climbing on the roof or walking fields or using tape measures, they lead to challenges, right? And satellite imagery and poor data create inaccuracies and change orders. So our vision at Scanifly is to streamline, automate, and centralize as much of the workflow as possible in order to make it faster, safer, cheaper, and more accurate for the industry. Right? And we know that getting good drone imagery is foundational to doing that for the surveying process. Okay. So with our software, we can help solar companies survey, design, and operate projects more effectively. Scanifly software is used by solar companies all over the world, and whether it be perfectly created arrays or shading analysis, sharing beautiful imagery, or exporting to AutoCAD or SketchUp, Scanifly customers are enhancing their workflows. And we know many of them are joining us on the webinar today, which we appreciate. Okay. So just briefly, Scanifly's workflow. Step 1, when you're going to go to the site and you're going to fly a drone and take pictures of the site's features. Then you'll upload those drone photos to our software, which automatically stitches them together to make a virtual replica 2-scale 3D model of the project. It is these phases right here where capturing data is most relevant, and that's obviously the most relevant topic that we're going to talk about today on this webinar. Okay. Once you have your 3D model, you'll design and analyze your project, and then you can export it to a variety of platforms for CAD files, bankable shade reports, sales imagery, etc. Here's some basics regarding the benefits you'll get from using our software. So you're definitely going to reduce time on site by using drones. You're going to assess with far better accuracy, especially than satellite imagery or other aerial data, and you're going to improve worker safety by staying off the roof, right? And so these are all the benefits, especially if you're going to capture great data. You're going to get fantastic imagery when you're using drone-based 3D modeling. We've got bankable shade reports as the only drone-based platform to have that in the US. And it's a fantastic solution for new builds, right? So these are all benefits that you'll get from using drone-based 3D modeling software, especially using Scanifly. Okay. And just a reference to how to fly the drone, we advocate flying with the point of interest flight path. This is best done to capture imagery at an angle or oblique imagery, and that's best used for getting fine-tuned details of project sites. So we usually recommend doing a context flight at a high altitude and a larger radius, and then several detailed flights at a lower altitude and a tighter radius. And this is a great way to make good-looking 3D models. Okay. Scanifly does a variety of continuing education, including partnering with NABCEP for CE credit. We offer this monthly, and we also do a lot of CE work with HeatSpring, which is a fantastic partner. Specifically about HeatSpring, they are our host today, and they're our curriculum partner, and we love working with them. HeatSpring offers more than 160 courses, including NABCEP training and a 12-week drone pilot bootcamp that takes you through from your Part 107 license all the way to flight skills, data gathering, data prep, and report production. We can't speak more highly about Brian, his team, and the whole HeatSpring group. If there is curriculum that you're looking for, they've got it on their platform. So I advocate going there after the webinar and really doing a deep dive because, when you join Scanifly, when you join HeatSpring, that's step 1. But continuing your education as you go through, staying up to speed on new technology, HeatSpring in particular is a great resource for staying ahead in the industry. Okay. All right, I'm now going to pass it over to my colleague, John Novak. He is going to share his screen. And so we're remote now as a team. So I'm going to allow John to share his screen and we'll continue the presentation. So John, over to you.
Great, thanks so much, Jason. Share my screen here.
Perfect. And while you're sharing, I'll introduce you. Okay. Great. So John started his career as a PV designer for a commercial developer called GeoPeak Energy. In that role, his scope covered not just design, but most aspects of the solar project's workflow. Okay. He also worked at NRG, where he designed over 2,000 systems nationwide and became a leading voice on quality control for projects. After experiencing a lot of the solar inefficiencies firsthand, he left to found and build Scanifly. John is OSHA and IREC trained and is a Part 107 drone pilot license. He also has a background in landscape architecture, horticulture, and GIS. So when it comes to understanding all of the aspects of solar and drones and putting it together to maximize imagery, I think John is the perfect person to walk us through these next items. So John, I'm going to turn it over to you.
Great, thanks for the intro, Jason. I really appreciate that. Hey there, Scaniflyers. Thanks so much for your time today. Really appreciate it. So Scanifly was born out of the idea of using reality capture and 3D mapped environments to accelerate project development and bring this real world context to the assessment and design process, where you can design for any roof and design for any structure, existing and proposed. So why reality capture? Well, when you assess the site and design a PV system using a 3D mapped environment, you have this canvas that provides real world context. And that real world context is super important when designing hyper accurate PV systems. So how can we capture reality? How can we digitize the real world so we can build solar PV on top of it? Well, let's capture reality using a drone, then design and analyze using a 3D mapped environment. This will provide that real world context that we need. So one method for 3D mapping the real world is called photogrammetry. And photogrammetry is the art and science of extracting 3D information from photographs. This involves taking overlapping photographs of an object, structure, or space and converting them to a 3D model. For this example, the artist used an array of DSLR cameras and the photogrammetry method to create a 3D model of this race car driver. Super cool. Here's another example where the artist used the photogrammetry method to help design this World War I memorial in Washington, D.C., which I believe won the design competition and is scheduled to be built sometime next year. Now, if you look closely, you can see the soldier and the nurse that are being 3D mapped here right there in the memorial. Really cool, really awesome. So here's another great example of photogrammetry. Former President Obama was the first American president to be 3D mapped. Now, there's a really great informative video that whitehouse.gov published about this. So let's watch it.
We're here at the White House working with the Smithsonian Institution on creating a 3D presidential portrait. And the system that we've brought to be part of this process is called our mobile light stage. It's right over there, and we're setting it up right now so that it can be used to record almost certainly the highest resolution digital model that's ever been made of a head of state.
The inspiration for the project of creating a 3D portrait of President Obama really comes from the Lincoln life mask in our National Portrait Gallery. And I have a Lincoln life mask with me today, and they're called life masks because these were directly taken from his likeness. So there was plaster put on his face, there were 2 little holes poked where the nostrils were so he could still breathe. And seeing that made us think, what would have happened if we could actually do that with a sitting president? using modern day technologies and tools to create a similarly authentic experience that connects us to history, to connects us to a moment in time, and connects us to a person's likeness.
So the process should go relatively quickly. We will invite the president to sit down. He will be surrounded in front by 50 custom-built LED lights, 8 high-resolution sports photography cameras, and an additional 6 wider-angle cameras. In about 1 second, as he holds his presidential pose, he will be illuminated by 10 different lighting conditions, which will change the polarization of the light, the directionality of the light, and will give us everything that we need to understand the shape of his face and how it transforms incident illumination into the images that we see of him. 10 years ago, it was just barely possible to think this could be done.
So here we have a structured light 3D scanner, and we're using this to scan the president. They're handheld, they're flashing a fringe pattern of light, and there are stereo cameras recording how that fringe pattern forms over geometry, or in this case, the president's face.
The president getting his likeness scanned, as cool as that is also about a broader trend that's going on, and that is the third industrial revolution. It's the combination of the digital world and the physical world that is allowing students and entrepreneurs to be able to go from idea to prototype in the blink of an eye.
It's been a few days since we've 3D scanned the president, and we're looking at some raw data on screen right here. So this is the data that came out of the handheld scanners that Adam Mattel and I were using to scan the president.
Well, this is the first bust that's created of a head of state from objective 3D scanned data. So this isn't an artistic likeness of the president. This is actually millions upon millions of measurements that create a 3D likeness of the president that we can now 3D print and make something that's never been done before.
All right. Really cool video. Really exciting stuff there. Now, if we take a closer look at the array that they used to 3D map former President Obama, you'll notice the cameras are positioned strategically at different heights and different angles. And this, this could be thought of as okay, we're 3D mapping a building, and if the building was here, that these cameras, right, the way that they're positioned, these could be thought of as different altitudes, right, as we're flying around the building, capturing more data, different angles and different altitudes here. Now, the reason for doing this is this maximizes the amount of coverage and ensures all areas of the object are 3D mapped in the finest detail. Even more important are the 50 LED lights in this setup, which are there to create the perfect lighting environment and create multiple lighting environments to 3D map the object as best as possible. So why use these examples here? So after all, we have zero control over the lighting environment, and we're not using an array of cameras, right? We only have one camera, and it's attached to a flying robot. And even though we only have one camera, the concept is still the same. We're using a batch of overlapping images to create a 3D model. So since we can't control the sun and the clouds, we need to understand more about how the camera works and how to take high quality photographs to create high quality 3D models. Now, why does the quality of imagery matter so much? So let's take a look at a few examples here. So here are some images showing white balance issues with the imagery. You could see here that the facade is pretty washed out here. It's hard to tell what's really going on there. Now, let's see what the 3D model looks like. If we were to create a 3D model using those washed out images here, you could see that the facade didn't really map that well. There's holes in the 3D model's mesh, and the facade is just white, and it's really hard to tell what's happening there. So not a really high quality 3D model there. Okay, so example 2, Here's another example of, there are some washed out images here. And this happens sometimes when you're using the auto settings with the camera there, where the white balance changes on the fly, or the brightness of the contrast changes on the fly there. And you can see it's hard to tell where the roof outlines are, especially where the dormers are there. And so let's check out the 3D model and let's see how that turned out. Okay, so you can see the 3D model is still, pretty washed out. Not much detail here, not a very high quality 3D model. Okay, so let's look at a before and after example. So the before image was taken from a batch of photos before the pilot knew anything about the drone's camera settings. The after is after the pilot adjusted the camera settings, it became a ninja when it comes to aerial photography. So notice the difference between the two. Huge difference. So the model quality will significantly change as well because of this. So let's check out the model quality. All right, so the before example is here. Okay, notice the facade is pretty washed out here. The texture overall on this 3D model is just pretty washed out. And let's check out the after example. Okay, significant improvement here when it comes to the texture map and improving the quality of that texture map for that 3D model. A ton of detail, looks great. So before and after. All right. Okay, so now with these examples, we went through the white balance and brightness examples. These are sometimes caused by the auto camera settings that adjust on the fly. So white balance and overall brightness and contrast aside, look for glare on the lens too. This can happen when flying at dawn or dusk. Also keep an eye out for those reflections on the roof as well. If there's just a few of those in the batch of images, you can just remove those and that's fine. So now let's go back to the before and after example. And in order to go from the example on the left to the example on the right, we need to understand how the camera works, what settings to adjust, and overall what we can do to become better aerial photographers. Oops. Let me just minimize this. Okay, and with that said, we'll end this section here with a poll. So do you adjust your camera settings? And I'll hand it off to Jason here.
Perfect. Thanks, John, for walking us through some examples. So just want to get a sense for how comfortable everyone is with changing their camera settings. As John walked us through what is photogrammetry and the different examples that we see in our software and when doing 3D modeling, Keith is now going to take us to how to avoid those problems and how to rectify those solutions. Before Keith jumps into it, we'd love to get a sense for how comfortable people are changing the camera settings, striking that balance of what the right type of imagery is to collect. All right, we're just going to wrap up the poll now. Okay. So we've got about 47% of people saying that they don't touch them at all. And then about 40% say that they only adjust a few of the settings. This is typically what we hear from customers, especially those that start out with us, where they just get the drone as it is and the settings as it is. So that's completely on par and makes a lot of sense. What I hope is by the end of this presentation and when Keith walks you through his portion, you'll feel more confident adjusting those settings and also knowing which settings to adjust in order to get the best imagery possible. We're going to do a handoff now from John over to Keith, who will share his screen and then walk you through a few items. Cool. And so let me introduce Keith before he gets started. Okay, and Keith, perfect. Yeah, if you want to go, perfect. So Keith Perry is the owner and lead drone operator at Hudson Valley Drones. While operating in the UAV space for nearly half a decade, he's built and maintained a successful drone services company in upstate New York. Prior to his immersion in the UAV market, he also pursued and operated successful ventures in HVAC and insurance. In addition to holding a bachelor's in criminal justice, he is a Part 107 and a certified holder, and also is a certified level 1 SUAS thermographer through FLIR's ITC program. He has extensive experience operating the Inspire 2 and Matrice 210 platforms with both RGB and thermal sensors, and is proficient in precision mapping using ground control points and data processing and drone deployment Pix4D. Keith also helps all of our customers at Scanifly with hardware selection, and really is a fantastic resource when it comes to understanding both what hardware to buy and how to best leverage that hardware. So we're going to have Keith kind of take us through a bunch of the different components as it relates to hardware and your camera settings to do the best that you can with managing exposure and lighting. So Keith, over to you.
Great. Thank you, Jason. And thank you for the introduction. For those of you who attended our first webinar, welcome back. For those of you who didn't, it's nice to see you. John did a fantastic job in the last section explaining why we need good photography and illustrating why we need good photography in order to create a good model. And just to reiterate, good photography equals good photogrammetry. John said this too, and this is something that I like to keep in mind, that I encourage people to keep in mind when they're using their drone to collect imagery. All your drone is a fancy camera that's strapped to a flying tripod, a flying robot. So while it's important to be a good drone operator and not crash your drone and be able to navigate that space, it's also important to at least have a high level understanding of how a camera works so that you can make sure your imagery is good. And if it's not good, you can make the adjustments in order to correct the photography and make it a usable product. So there's always a debate amongst photographers on whether you should use auto settings or your manual settings in your drone when you're flying photogrammetry missions. We always recommend that you start off by flying on auto settings that probably works 50 to 60% of the time, maybe more, and it just eliminates one thing that you have to worry about while you're flying your drone. You can then worry about doing your point of interest mode and making sure that your field of view is correct and you have your subject in your field of view. But if auto isn't producing what you need it to produce, and if it's producing blown out imagery like John had shown, or excessively dark imagery where you can't really determine detail in the images, if it's creating blurry images, or if you're getting glare, that's when we might have to go in and start making manual adjustments to the settings of the camera. So I thought it was important to talk about how a camera works fundamentally. All a camera really is a little box that allows light to come into it, and that light strikes some sort of photosensitive surface. It used to be film. Now almost no one uses film. We use digital cameras. And while that technology has advanced, the fundamental mechanics behind that are the same. We can adjust three things in order to get the proper amount of light, or the amount of light that we want, into the camera and onto the film, so that we ultimately have the best photograph at the end of the day. Three things that we can control are shutter speed, aperture, and ISO. And we're going to go over those momentarily. So this is the exposure triangle. The exposure triangle is a visual representation of what we can adjust in a photograph in order to correct certain environmental issues. Along the bottom, you'll notice shutter speed, and that says 1/4 second to 1/8,000th of a second. And that indicates the amount of time that the shutter is open and exposing the light of your subject to the film. On the left side, you'll see the aperture. The aperture refers to an orifice in the front of the camera or in the lens that opens and closes and allows a certain amount of light to come through, and it really meters the light. And then to the right is your ISO, and your ISO refers to the sensitivity of your film or the sensitivity of the photosensitive surface, the sensor in the instance of a digital camera. And we can adjust all these based on certain environmental conditions to give us the proper exposure and what we need. So first we're going to talk about shutter speed. Shutter speed refers to the amount of time that the camera shutter is open and exposing light to the image's sensor. The longer that it's open, the more light there'll be exposed to the sensor and the brighter it will become. Now, if you find that your images are overexposed or have some ghosting or motion blur, you might be running into a situation where your shutter is open for too long. You should shorten your shutter speed to reduce the amount of light that comes through into the sensor. But one thing that can happen is if you shorten your shutter speed or lengthen your shutter speed, excuse me, it can cause motion blur. So you'll see on this image down at the bottom, the longer your shutter is open, the longer an object that is moving can expose itself to the sensor and create blur. So that's something to keep in mind as well. After shutter speed, another feature or another control that we can adjust is the aperture. The aperture refers to the openness of an orifice in the camera lens. The wider that orifice is open, the more light gets in. So if you find that your images are not properly exposed, you can also adjust the aperture. The wider the aperture as stated, and in this image on the left, you'll notice that this orifice, or this is an indication of the orifice almost wide open. You'll notice that it's letting a ton of light through and this image is blown out. Here towards the center, f8, you'll notice that this is a pretty well exposed image. Even f5.6 or f11 are better than on the extremes, but you really want to aim for something here in the center, which indicates the proper exposure. You can see all the lights, you can see all the darks, and nothing really loses detail. Likewise, if you have it too far closed, you can have an underexposure situation, which is better than an overexposure situation because you can still get some detail out of it, but at the end of the day, we aim for proper exposure. The last lever that you can control when you're taking your digital photography is your ISO. Now, the ISO refers to the sensitivity of the camera sensor. We typically recommend that you keep that as low as possible, which is 100, which will reduce the amount of grain in the image. If you're in a low light situation and adjusting your shutter speed and the aperture doesn't help, you can also adjust your ISO, but be careful. The more sensitive you make your film and the higher your ISO, the more you risk having a grainy image. You can see that again along the bottom here. To the left, ISO 100, this is a nice clear view. You look in the sky, there's really, it looks like the sky. If you come over here, as they're increasing your ISO, you see this noise and this graininess in the sky, and even on your subject, and that's really not good for a high quality deliverable. So one tool that you can use if you're running into a situation where you have too much light, you can also use an ND filter. An ND filter is a neutral density filter, and it's essentially sunglasses that you can put on your drone and allows for flexibility when using certain photo and video techniques. You can use it in tandem in some of the other recommendations that we've made, such as adjusting the shutter speed. And some drones, particularly the Mavic 2 Zoom and the Mavic 1 series, don't give you the ability to adjust your aperture, so you have no other option but to use your ND filter to meter the light that's coming into the image. You can also use these in situations of glare, where you might have bright siding, a metal roof, or even a light-colored roof could create glare, and the ND filter can help with that as well. Photographing light colors, this is a common issue that people run into. And again, having a light-colored roof or light-colored siding, bright white, yellow, anything bright can also often be overexposed and create glare on bright days. There's a few techniques that we recommend to minimize this. One would be to take your photogrammetry on days that aren't super bright. Days that are overcast are great, or even partly cloudy, as long as you keep that cloud cover consistent throughout your flight. But that being said, we can't always control the environment. I mean, if you have a choice, you can, but generally speaking, if we wait for an overcast day, we might be waiting a long time. So you can also shorten your shutter speed, but the key is to adjust your shutter speed enough so that there's some detail on the roof, but not so much that the rest of the image becomes so dark that you can't use it. So you want to find that central, area between proper exposure and not under and overexposure. And as stated before, you can use an ND filter to assist with that. The last point that we're going to touch on here is the histogram. So in the last slide, we were talking about finding something that wasn't too bright and wasn't too dark. And the histogram is a tool that you can use to visually represent the exposure of your image. The histogram is a feature on all DJI drones, and you can get to that in your settings, and it'll float over your screen while you're flying. And what you can do is keep an eye on the histogram while you're flying and adjusting your settings. You'll notice here that this is a representation of an image that's taken at several different exposures, and the corresponding histogram at the bottom. So over to the left here, we have a dark image, and you'll notice that the histogram is bunched up to the left. That means that it's underexposed and could be, too dark, obviously. The second one over is your normal exposure, and you'll see that normal exposure is, a pretty uniform dispersion throughout the histogram. And then the other two on the right are overexposed. You'll notice the one all the way to the right is very overexposed. You notice it's very bright, and you lose a lot of detail. And you can see that the histogram is bunched to the right. That's indicative of an overexposed image. So focus on the histogram and try to make sure it is as uniformly distributed as possible. So we'd like to end this on just a few takeaways. Always start using your auto settings. It works the majority of the time, and you should start with that. But if you do a flight on auto and you review your imagery before you leave the job site, which you should always be doing, you should make the appropriate changes, and you should have the know-how to make the appropriate changes, and hopefully this presentation gave you that. After reviewing your images, make the adjustments if you need to, and check your deliverables again. And if you have to fly it again, do that. It's a lot better to fly a mission 2 or 3 times, or redo it when you're on site, as opposed to leaving and going back to the office and getting ready to upload everything, and then realizing that half of your imagery isn't usable, and then you have to go back out again. It's just not a good look for efficiency, and it's not a good look, to your customer. And finally, before uploading to Scanifly, go through and actually remove the images that have glare or other issues that might have missed. John posted a great YouTube video on the Scanifly channel recently, and it's a super useful tool for you to go through and figure out which images are useful and which ones you should remove in order to improve the quality of your model. And finally, practice. A lot of this isn't intuitive, but the more you do it, the better you'll get at it. And just keep practicing. Thank you, everyone.
Awesome. Thanks so much, Keith. Perfect. You just go to the next slide. Yeah. So we want to recognize HeatSpring again for hosting us. We really appreciate them leading this webinar, recording it, and it will be posted on both their site and our YouTube page for viewing afterwards. And we're now going to open it up for question and answer. And we'll all show our faces and open up our videos. And I'm going to moderate the questions, and we'll relay them to the respective content expert accordingly. Okay, so we'll give it a couple seconds for questions to start coming in, and then I'll start channeling them to the respective expert. So the first question that's come in, and I think both John and Keith, this could be, both of you guys can address it. We had a question come in that what are some strategies for managing glare from a highly reflective flat rooftop? I know we showed some examples with those types of roofs, and we talked about some of the settings that you can adjust, but let's put it together. So just repeat the question again. What are some strategies for managing glare from a highly reflective flat rooftop? What would you guys do if you got on site and you saw something like this? So Keith, if you want to go first, and then John, you can go second.
Sure. I'm a believer that an ounce of prevention is worth a pound of cure. So I always check the conditions on site beforehand. And if I can adjust, my timing to have an overcast day, that would be the first thing I would try to do. Although that's not always possible. So once you get on site, and if you notice there's a reflective roof, that might be a light colored roof, that might be a a metal roof. Try it on auto if that doesn't work. Adjust your shutter speed, put an ND filter on. Both of those could work. A polarizing filter could also work to adjust that as well. But yeah, I would go through those steps. Absolutely.
Awesome. And John, any additional thoughts?
Yeah, so it's always best to 3D map. So just echoing Keith here, it's always best to 3D map highly reflective roofing materials on an overcast day. If if that can't happen, all right, then if either removing those images that have that reflection out of the batch of images before uploading. That's a great way to deal with those reflections, and also to adjusting the camera settings to tone down that whiteness, the brightness that's in the imagery there as well. ND filters also help. You maybe using one that's a bit subtle, because there's different filters you can use. So using a more subtle filter can help.
Awesome. And guys, I want to ask a follow-on question to this. So let's say you follow what you've suggested, right? You've adjusted your settings, maybe you've used an ND filter, and what happens next, right? You fly your drone, and what are some best practices to then address potential issues? Are you supposed to look at the flight controller and watch the pictures? Should you review them afterwards? Do you have to review them afterwards? Because you can do all the preparation you want and it still might not go accordingly. What are best practices once the drone is in the air, how you should take it over to finished product?
Yeah, you should
you
always
do John this time, then Keith.
Yeah. So you should always, review those images, or watch the images in your camera viewport in the app as they're being taken. Sometimes the auto settings can adjust on the fly. So if you're keeping an eye on those images as they're being taken, then you can adjust those radial dials on your RC, right on the remote controller, in real time, and adjust the exposure and other camera settings that you have tied to those radial dials. You can quickly adjust on the fly.
Yeah, I would agree with that. Keep an eye on it while you're flying, but it's also, it can be challenging. I mean, as a practical approach, it's challenging to look at your imagery sometimes and also fly the drone and make sure it doesn't hit something. So first of all, make sure your drone doesn't hit anything and do the flight first, and do your best to keep an eye on the imagery and adjust it when you can. But then, even if it looked good, always review it at the end. Bring your laptop on site and spend 5 minutes and just, thumb through the images real quick and make sure it's good.
Awesome. And I guess a final question on this specific topic, when you look at the overall workflow, do you guys ever adjust the images after they're taken? Doing whether it's digitally or you're back on the computer, you happen to get home and you didn't fully review everything. Did you ever see a situation where someone will adjust the images before they upload them to make a 3D model?
Yeah, it's not best practice to batch Photoshop those images. If all of the images have reflection issues and brightness contrast issues or white balance, if you batch Photoshop those images, sometimes that result, it's not going to be what you're looking for. Sometimes when you edit those images in Photoshop, they can be a bit more grainy, and the resolution can be reduced, and the quality of the imagery can be reduced as you edit those images in Photoshop.
Great.
Yeah,
Keith, anything to add to that? Okay.
If you get into a jam, you got to do what you got to do sometimes, but it's not a good practice. So don't do it if you can at all avoid it.
Great. Good to know. Next question. We talked about ND filters. Someone asked about polarizing filters. Does anyone want to address what those are and when are they advisable to be used? Keith, maybe I'll direct this one to you first.
Yeah, so a polarizing filter can also be used to reduce glare. We use the term glare, or I find people use the term glare a little bit synonymously. So to me, like, right, the definition of glare is sunlight that's reflecting off of a reflective surface, whether it's a metal roof or water, right? Those would be the two really reflective things, and a polarizing filter could also help for that. But a lot of people use the term reflective synonymously with overexposed and bright, and it's just important to pay attention to those two differences. So yeah, polarizing filter could help with reflective situations as well.
Awesome. Next question, is there any specific sources that you'd recommend for adjusting your drone or your photo settings? Any training materials, anything that is kind of a manual that will help you better understand the different settings and navigating which ones to turn on and off or up and down? Any recommendations, guys?
Yeah, so just searching through YouTube, there's some great tutorials out there. I think, just searching through YouTube is fine.
Agreed.
Any good resources? Okay.
Agreed that, and like in all seriousness, just get out and fly your drone a little bit, and just 5 minutes of messing around with the settings, hands-on, can take what you see on YouTube and really just help drive it home doing it in person.
Awesome. And if for anyone who's joined us, if you have a specific question about settings, you can also email us directly. We're happy to provide resources or helpful wherever we can. Okay. The next question I think is going to be particularly relevant for those people who fly in areas that are go in and out between sun and cloudiness, and also in and out between a drone flying in and around trees. So whether you're in Florida or Alberta or everywhere in between, I think this is actually going to be relevant. So I'll read the question here. So when there's a mix of sun and clouds, right, where the sun is full sun in 1 second, and the next second you've got clouds and it's kind of providing overcast or shade on the area, and it keeps changing back and forth. So that's the lighting difference that John talked about. Does that matter if some of the photos have one lighting versus another? How do you avoid it? It's very tricky at times when the drone's already in the air and all of a sudden you have a cloud that's come by. So how do you navigate that circumstance? What do you do during and after? Is there things you can do before? So Keith, why don't we start with you, and then John, I'd love to share your thoughts as well. How do you navigate those situations?
Sure. Auto settings can fix a lot of those issues, right? If you're going from bright sun to clouds, and your auto settings will adjust. So like under ideal circumstances, your auto settings should be doing all of this for you. But sometimes it doesn't happen. So, if you can, you can look up, and if you see one cloud in the sky, like, you can wait and kind of make your best guess. If it's really, really dramatic, you can pause your point of interest while you're in the air and hover for a few minutes and wait for the lighting to improve, or go back to normal and then keep going. So that's an option too.
Yeah, so the auto settings, should adjust for you as that lighting is changing. And if it's not, and you go back to the office, or you're in your truck and you're uploading those images, and you notice there's a pretty significant difference in lighting, right, in the images there, just remove those images from the batch, and that's fine. If it's not a significant change, it's pretty subtle, then just include those images, and the software will do its magic and disregard whatever it needs to disregard. So.
And John, on that note, we often get asked, should I remove these images? We say, yes, you should remove them. But what happens if there's like a certain chunk of the POI that you have to remove? Or should we be removing every other? How do we know when there are too many images that we've removed and we're going to affect the 3D model quality?
Yeah, it's a great question. That's when photogrammetry becomes an art more than a science. Now, and every photogrammetry engine, including Scanifly's, is like that. So, it just, it's a matter of practicing and knowing what that threshold is, and what the limits are. So yeah, it's hard to give a straight answer there. I apologize for that.
That's fine. That's fine. That's fine. I'll say, you know, John and Keith are much more photogrammetry experts than I am, but in practice, what I've found is if you're removing a quarter to half of your POI, you're probably not going to get a good 3D model. And so you want to strike the right balance. If you're removing a small sliver, the remaining pictures should have coverage because your overlap, you want it to be roughly 80 to 90%. So you should have coverage. You also want to assess if that area is critical for the objective of your 3D model, right? For, you know, designing solar, which is what you would do in Scanifly. So John definitely hit it on the head in terms of that is where the art versus the science come in. But you also want to think about what the objective is for when you create the 3D model. And if you remove those pictures, how much that will affect that objective. Okay. We have a bit more of a technical question here focused on shutter speed. So I'm going to send this one to you, Keith. You know, so when you recommend to lower our shutter speed, does it mean that you're going towards the quarter, you know, 1/4, or does it mean you're going towards the 1/8000 end of the settings range? So if you could just clarify what direction you're going in when you're adjusting shutter speed, specifically when you're lowering it.
Sure. I should have caught myself when I was saying lowering. We should use shortening your shutter speed and lengthening your shutter speed. So shortening your shutter speed is making it a quicker flash of your shutter, and lengthening your shutter speed is having your shutter longer. So if you're shortening your shutter speed, you're bringing it closer to that 1/8000th because you're shortening the amount of time that the light is exposed to the sensor. And then having a long exposure, a lengthy shutter speed, can let more light in, but then you also, you know, have the potential of running into a motion blur situation. So hope that helped clarify it.
Awesome. Thank you, Keith. We have a high-level question that I'll tackle. What are the ideal altitudes and radiuses for a context and a detailed flight, and specifically when you're flying in a point of interest flight path? So for the context flight, you know, we always say is you want to fly to the highest point of the site, whether it's the top of the tree or the roof, and then go above that by, let's say, 20, 30, 40 feet, you know, 10, 20 meters or so, right? And so that is site dependent. For a typical residential property, you're looking 60 to 80 feet. Unless you are in like the Pacific Northwest where you have 120-foot tall trees and your context flight will require you to fly at 150 feet, right? For detailed flights, you want to fly with the same idea in mind above the highest obstruction, but in that case, you're usually flying around the roof plane. And so you're going just right above the roof plane or right above that obstruction, okay? And I'll reference, we have on the Scanifly website, if you go to the resources tab under guidebook, there's a ton of content on, I think, 30 or 40 example sites and exact quantification of the parameters of how you want to fly and when you want to fly it, okay? We have another question here regarding Scanifly pricing. I'm going to not address that just because that is not as much in the spirit of what we want to accomplish on this webinar, but the individual asked that. I'm happy to talk separately about that question and we can get into that there. Do you normally, next question is, do you normally fly in orbit with the drone taking the photos automatically or manually taking the photos? And are there implications for how that would affect exposure and lighting? And so, John, I'm going to defer this one to you. You know, automatic POIs, manual POIs, what's the best way to get the best lighting that you're going for? I know we talked about this on our tree webinar that we did before, but let's think about it from the lighting perspective. What do you recommend?
Mm-hmm. Yeah, so I recommend adjusting your camera settings before even executing on that POI mission, right? So make sure that, you know, so once the drone is off the ground, you're hovering, you know, the camera is you know, you're looking and at the camera viewport to see what the lighting looks like, adjust those camera settings, and then execute on the POI mission. And, you know, whether it's a manual or if it's an automatic picture taking process, right? Those camera settings that you've adjusted prior are going to be used when you're taking the picture. So it's not going to really matter as much if it's manual or automatic. Just make sure you adjust those camera settings before you execute the POI.
Keith, I would love to get your thoughts on this as well, but I'd love for you to talk about it from the lens of when you first started flying drones. A lot of our customers start with us having never even flown a drone in their life. And ideally through our content and through their hard work, they get up to speed. So Keith, put yourself when you started flying drones into where you are now. I would love for you to address the question of automatic versus manual, using your hardware to the best of the ability, and then also for maximizing the best exposure. What do you think?
Sure. So I'm a believer in, try auto first. Always do auto if you can. Well, I guess there's two sides to this question, right? Auto versus manual camera settings, which is try auto. And if auto doesn't work, like John said, before you're even doing your POI, adjust your settings to get it where you need it to be. Then is the, auto versus manual flight settings, right? A point of interest flight autonomously or a point of interest flight manually. An autonomous flight mode is going to make a way smoother path than a manual flight path. I mean, even if I try to do a point of interest manually, I mean, it would be a pretty good circle, but it wouldn't be as perfect as, the DJI flight software does. So try to do that manually if you can. I'm sorry, correction. Let me try to do that autonomously if you can, unless you have like an extenuating circumstance, like a ton of trees or a ton of power lines, because it's more important not to crash your drone. The second side to that is you can manually take the images every 2 seconds, or you can set your camera on interval mode to take a photo every 2 seconds. I would recommend that you do the autonomous, have it take a photo every 2 seconds, because that increases the likelihood that you have the right overlap and is one less thing you have to be doing when you're flying. So regardless of whether you do a manual or an autonomous point of interest, always use that interval mode and take an image every 2 seconds.
Awesome. Thank you, Keith. Yeah, no, that's great. We've got another minute on the clock, but we have a couple more questions. So we're going to go a few minutes over for everyone's benefit, hopefully. The next question, I think this will be for you, Keith. It's about filters again. Can you stack filters is the question. So combining polarizing and an ND filter. And I guess when you answer that question, I'd love also if you can again kind of bifurcate, what are the differences between polarized and an ND filter?
So an ND filter, it can be used for several purposes. Most commonly, it's used to meter the light coming through your camera to get the appropriate shutter speed in video, or to meter the light coming through when you're doing photography. And there's like a lot of nuanced reasons why you might use it. So there's that. A polarizing filter can be used to reduce glare after sunlight has reflected off of something and become polarized. As for stacking them, I don't know for all circumstances, but what I'm thinking about right now, most drones are outfitted with an ND filter or polarizing filter that literally screws on and doesn't have a way to kind of stack one on top of it. So I think that might be a hardware limitation and something that's, could be invented that could be very helpful. So I don't think stacking them would even be practical or possible in most situations. So I'm thinking that's a no.
Okay, awesome, Keith, thank you.
No problem.
In the spirit of hardware, one follow-on question that we're seeing is, are there drones that you recommend are flown to maximize getting the best exposure possible, right? So how does a Mavic compare with a Phantom series or some of the larger, more expensive drones like the Inspire or the Matrice, where you can add cameras to it? So I'm going to split this into two parts for you, Keith, keeping it complicated, right? Which drone would you recommend? And I guess also, are there certain cameras or add-ons that you recommend with drones where you can do that capability? So I'd love to get your thoughts on the kind of the drone hardware landscape for this topic.
Sure. I'm going to simplify this as much as I can. So if you're going to ask me the best drone for the application of the Scanifly platform, given a ton of different factors, the capability of the drone, the availability of the hardware, the history of the availability of the hardware, I would say the Mavic 2 Pro is probably your best bet because it's got a 20 megapixel camera, which means that it's very, it's a high quality camera. It has high dynamic range, which means it's able to capture a large, a large range of colors in an image. And it is relatively affordable. It's, a fraction of the price of an Inspire or a Matrice or anything like that. So Mavic 2 Pro is typically what we recommend. You can make an argument that the Phantom 4 Pro might be better in certain situations, but the Phantom 4 was not manufactured for a while and then was manufactured again, which is typically why I don't recommend it, because DJI's, supply chain can be somewhat unpredictable. So blanket statement, I'd recommend the Mavic 2 Pro. You know, the Inspire 2 does have options for better, you know, cameras, higher quality cameras. The Matrice, same thing, as well as infrared, but I don't think that's necessary typically. So, you know, if you can spend $2,000 all in on a drone setup versus 5, 6, 7, 10, 12,000 on a setup, I'd go with the more affordable option. So, yeah.
Perfect. And John, specific to Scanifly, taking it one step further, you know, in your knowledge of drones, does it matter, right? When you think about the variables of what it takes to create a good 3D model, does the camera landscape that Keith walked you through, how important is that vis-a-vis the other variables of getting drones right with the right angles and with the right coloring? And, you know, how do you see the drone type mattering for creating good 3D models on our platform?
Yeah, you know, it's a great question. You know, all the drones that are out there now, I think, have, you know, really good cameras. You know, I personally have a really old Zenmuse X3 camera, right? And it still works. It's still just a great high quality camera, and it's really old now. So, you know, those cameras that are being mounted to the drones now are really high quality. And, you know, echoing Keith here, the Mavic 2 Pro, and, you know, that has a really great camera. I think they've enlarged the sensor on that camera for that specific drone. But, you know, they're good quality cameras. For me personally, you know, choosing the best drone for site assessments is a high quality. The drone needs to have a high quality camera, but B, you know, does the drone set up and break down quickly, right? The high quality camera is going to get you a high quality 3D model, right? So check that box. That's great. The other side of it is it very efficient? Is very you know, what does the process look like for setting up and breaking down? You know, that's not related to model quality at all, but, you know, that improves your user experience on site.
Great. One final question we have here, and I can address this one. In autonomous POI mode, what speed do you recommend taking your images? Typically, we recommend anywhere from 2 to 4 miles per hour. Obviously, if you're flying a much larger site, your context flight might go upwards of 5 miles per hour. But just certainly beware that, you know, you want to avoid flying too quickly and therefore creating a blurry image. Also beware of, if you're flying at a certain speed and it's windy, you'll create a blurry image with vegetation shifting as well. And so just be cognizant of flying too quickly as it relates to the imageries that you're taking. So that wraps up our questions. I just want to, you know, Keith or John, any final points to, we've got one more question that just came through, so I'll address it real quick. And then we'll, this gives John, you and Keith, you guys give a moment for final thoughts. But the last question is, with the Phantom 4 in its mechanical shutter mode, while the Mavic 2 Pro has an electronic shutter. So Keith, this one might already be pointing to you, but presumably this affects the quality of the overlying photos and the speed of creating the model and everything. So do you need to hover or capture, and what do you recommend? Well, with the Phantom, you know, can you take photos continuously? So what's your perspective on kind of the comparison of these two drones and the two different shutter options?
I'm happy that this question came up, because the way that I worded my last answer was very careful, because this is the variable here, right? So the Phantom 4 Pro has a mechanical shutter. The Mavic 2 Pro has an electronic shutter, a global shutter versus a linear rolling shutter, right? So what that means is when the Phantom 4, or really any drone that has a mechanical shutter or camera with a mechanical shutter, it takes a capture of every pixel at the same time. An electronic shutter does it rolls across and takes the pixels in a different, not all at the same time. So there can be a slight variance, and that is why on the last one you can make the argument that the mechanical shutter could be better because of that situation. But given a few factors, one is that the flights that we're doing in the Scanifly platform are done at a relatively low speed. that effect of the mechanical shutter versus the electronic shutter or electrical shutter is lower. And the other thing is, I mean, the Phantom 4 Pro, they didn't make batteries for it, and they didn't even make the Phantom 4 Pro for, you know, a while, going back a year. So there's always this balance between figuring out what the client wants and what the end client, like, right, the solar company needs. You know, do we recommend you buy a Phantom 4 that might not manufacture batteries starting tomorrow, or the Phantom that hasn't had any eruption in the supply chain? So there's always a balance there. But yes, that is the big difference between the two, and that's a debate between the two that you can have. But you can make the appropriate adjustments with the Mavic 2 Pro to get a deliverable that's within parameters.
Great. Thanks for clarifying that, Keith. If there's follow-on questions on that exact topic, we're happy to speak about that.
Happy to chat. That's a long conversation.
Cool. So John, any final thoughts? And then Keith, this will give you some time to think about your closing thoughts.
Yeah. So final thought, practice makes perfect. And, take the drone out and just have some fun, right? Experiment with those settings, go through each and every camera setting and just experiment, see what it does in different lighting conditions. Even if you take the drone out for recreational use and you're not 3D mapping anything, you want to take a great picture of a sunset or for real estate, a real estate side gig or something, to just experiment with those settings to see what works and what doesn't in different lighting conditions and so on. It's a lot of fun, and just keep practicing, and it will be, you'll become an expert in no time.
Thanks, John. That's great feedback for the group. Practice makes perfect, right? So that makes a lot of sense. Keith, your closing thoughts.
Yeah, I'm going to, resonate what John just said there. Practice a lot. The information we gave you here both can apply to photogrammetry, but it also can apply for using your drones to take marketing photos or, other reasons, right? So, you're grateful enough, you're lucky enough to have a drone that you use to create a model of the site that you're going to be installing solar on, but use that drone to take photos afterwards of the after product and, put it on Facebook and Instagram. And while you're doing that, practice using the camera settings and get familiar with it. And the more you do that, the better you'll get at this whole process. And eventually it'll just be, second nature.
Fantastic. All right, great, guys. So again, I guess the emphasis is on practicing. We know everyone's super busy with their schedules, but when you can get out there and find time to take pictures with different environmental conditions or different lighting, it's good to play around with those settings. We find that, and Keith mentioned this on the prior webinar, right? Your drone is really the tools, and the tools that allow you to drive your business. And so as much as you can get familiar with those tools, or we at Scanifly or Keith at his company or Brian at HeatSpring can be helpful with that, please let us know. So if there's a question that we didn't address or you have a follow-up thought or question, please reach out to us. We're happy to be a resource. Again, we want to thank HeatSpring for hosting our webinar and being our curriculum partner, and Keith for being our real expert on this topic on the hardware side, as well as Scanifly's hardware partner. This is being recorded, and we're going to have it on both Scanifly's YouTube channel and HeatSpring's library, so you can always look back at it. And if you have any other questions, please reach out to any of us. We should be following up with a survey. So thank you to everyone who stuck with us, who joined us, and we hopefully will build the future of drones and solar together as we go forward. Thanks so much, and have a great rest of the day.
Thanks, everyone.